All right, let's go ahead and take a look at some of the things that might end up being on the lecture final exam. So, as with the lab, if you happen to be in that one as well, a lot of these questions are recycled. So, quiz questions and questions worked in the lecture room and things that have been on videos will show up in some version on quizzes and discussions, exams. They get recycled or reformatted in some way. Now, some things that you don't have to worry about on the final exam are the factor questions and anything that requires direct calculation or remembering a formula. So you're not going to see something like this, but it might be entirely reasonable that you need to know what kind of the difference between a longitudinal wave, transverse wave, torsional means twisting, surface means like across water. So, again, you that's fair. Similar to here, again, short definition, short answer, that's reasonable. You're not going to have any of these. Students call them the factor questions because it says the word factor in there a couple of times. Now there's a variation of these that I'll show you in a minute. Reduces the math, no direct calculation necessary, just sort of eyeballing and you can see how things change. And I'll show you one of those in a minute. I want to find some examples of things that, like here, I'm not going to require you to specifically memorize a formula. There are some cases where knowing a formula already might be slightly useful, but in most cases, if you need a formula, I'm going to give it to you in the question. So you are not going to need to do something like that. I haven't given you a formula sheet. I don't want you to use your own formula sheet. I want you to use reason and think it through and use our concepts to figure stuff out. So again, fair game for anything that's short answer like this, not going to have anything that is a factor type question with a calculation. So let me see. Again, not one of those. Some of these that change depending on where you look them up. So that's not good. Similar to early in the semester, the relativistic limit, like how fast something needs to go before relativity matters, that technically changes depending on where you look it up. It's almost like an opinion, so that is excluded from the group. Typically, variance like this with units is not on there, but it is useful to know that like newtons are force and joules are energy and work and things like that. So let me see. Know about the different types of energy, potential versus kinetic. Rolling, we don't really talk about because rolling is usually used in conjunction with something else. So, okay, then let me find a big empty space. I can probably use this over here. So yeah, I think that'll be good. If you took the midterm, you may have noticed some increase, decrease questions, what some of the students have been calling them. Those are technically stripped down versions of these factor questions where you don't need to already know the formula. It's given in there. You don't need to calculate anything. In fact, there are no numbers. So, I guess technically you could make some numbers up, change them, and see what happens. But let's say that we have a random formula. So I'm not going to give you a real example. Let me say we've got A times B equals C times D. Okay? And the question tells you to solve for B and then change something and then see how the answer would be affected. Okay, so let's say that I want to solve this for B. Technically, a little bit of algebra skills would technically be useful. But if you reason through, you can kind of figure stuff out without actually even any algebra. All right, but let's do the algebra approach first. If I wanted to solve for B, then A is next to it. These are multiplied, so division is going to bring that under. And so if I had something like C times D over A, because I divided, I brought that under, then I'd want to look at what's going to happen between these different pieces. Basically, the placement of the variable. On the exam, these aren't going to be A, B, C, D. They might be F for force, D for distance, V for velocity, P for pressure, little p for momentum. Like it could be a bunch of stuff. But this just as a practice example. What we want to think about is what's going to happen to B as an answer now if I start messing with these different variables. So let's say I work a version of a question, I plug in numbers, I find some value. Whatever that value is actually not important. If we look at these different variables, so, if I look at C is in the numerator of this part of the answer of the formula. So if I increase it, if I make it a bigger number, then that's going to give me a bigger answer. So sometimes it helps to think about pizza. If you increase the numerator, it's like having more pizza. And if you don't change anything else, then that means at the end you get to eat more pizza. D would be similar because again, it's at the top here. It's in the numerator of this fraction. So if I increase D, I'm going to get a bigger numerator, which means I'm going to get a bigger answer. So anything that's in the top like this tells the truth. Because let's say I make C smaller, then that's like having less pizza, and then I'm going to have, less that I'm going to get to eat. A, on the other hand, and I'm going to switch colors to stress this a little bit, A is different. A is in the denominator. A lies. It does the opposite of what you expect. If I make A bigger, that's like having the same amount of pizza, but now I'm sharing it with more pizza and more people. And if I have, more people eating my pizza, if I'm dividing by a bigger number like this, then I'm going to have less left over. So you want to think about it in terms like this, that if I rearrange my formula, and it doesn't matter if there's squares and square roots, that's just going to mean that the change is going to happen, more quickly or less quickly, but it'll still go in the same direction. A is going to lie to you. If you make A smaller, you're going to get a bigger answer. You make A bigger, you're going to get a smaller answer. You can also kind of look at that back from the original part. So like when I said that you didn't technically need algebra to figure out what was going to happen. If I make C and D bigger, either one or both, if I made these bigger, then that's going to multiply and that's going to give me a bigger answer here. Technically, I would end up dividing, but that wouldn't change anything. So the things that are away from whatever you're looking at, the thing that's away from B is going to tell the truth. If I make C smaller or D smaller, technically, if I make both of them smaller, then my answer would get smaller. These tell the truth. It's the ones in close that lie. So A over here, it lies. If I make it smaller, then that means when I solve around, I'd end up dividing and I get a bigger answer. So A is going to do the opposite. It's going to lie. These other ones tell the truth. So I know it's a weird little analogy, but it's something that can help out. It's not going to be completely random. A lot of people are picking, just whichever one matches, or they're picking that it cannot be determined, or an answer choice like that. Technically, these are 50-50. They either go up or they go down. We should be able to tell. And again, the placement of the variables, you can figure it out beforehand or after you solve, but those are the things that are going to help you figure out how that's going to change at the end. All right, let's skim through and see if we find anything else. Again, anything with a direct formula, I'm not going to ask you to memorize, but if you needed it, then this could be something else that we could solve. So, let's say that you had the velocity of the wave is equal to the frequency multiplied by the wavelength. If I told you we were going to solve this for frequency, so again, now this is a real formula with real variables, we would want the lambda for wavelength to divide and to go under, and we'd have V over lambda. And then remember, anything that's above the line tells the truth, and anything that's below the line lies to you. So if my velocity increases, then that means that my frequency will increase. If my velocity decreases, that means my frequency will also decrease. Remember, lambda lies though, so it's on the bottom, it's in the denominator. Or if I looked at it from before, it was in there next to the variable I was looking for. If my lambda goes up, if I have a bigger wavelength, then my frequency will drop. Wavelength and frequency are inversely related. This is something that's come up several times. That specifically means that they move opposite ways when you make changes. A bigger wavelength is going to be a smaller frequency. The other way around, if my lambda decreases, then that means my frequency goes up. Okay, so really short little review on this one, just because a lot of questions are very similar and a lot of them are, definitions like this. So run through. Again, ignore anything that has direct calculations or says factor, because those are going to be reworked in a version similar to these. Anything though that's asking you for short answer is fair game. So hopefully that helps. Hopefully the test is not too bad, and good luck.